How much heat transfer is necessary to raise the temperature of a 0.2 kilogram piece of ice from negative 20 degrees Celsius to 130 degrees Celsius, including the energy needed for phase changes? Here we're going to use Q equals either mc delta T or ml, depending on whether we're raising the temperature of something or changing its phase. We first change the ice from negative 20 degrees to 0 degrees, then we turn it from ice at 0 to water at 0, then we turn the water from 0 degrees to 100 degrees, then we turn it from water at 100 to steam at 100, and finally we raise the temperature of the steam from 100 to 130. When we plug in all the numbers for that, we get 619,200 joules. Part B, how much time is required for each stage, assuming a constant 20,000 watt rate of heat transfer. Step 1, to warm the ice to 0, the mc delta T there is 8360 joules, and at 20,000 joules per second, that only takes 0.418 seconds. Step 2, to melt the ice, this is M times LF, 66,800 joules, that works out to 3.34 seconds. Step 3, to get the water from 0 Celsius to 100 Celsius, that takes 83,720 joules, or 4.186 seconds. Step 4, to turn the water into steam, this is an MLF, or MLV rather, we get 451,200 joules, or 22.56 seconds. And finally, to raise the temperature of the steam, that's mc delta T, 9,120 joules, or 0.456 seconds. Part C, make a graph of temperature versus time for this process. Notice that when we look at this graph, first we have a linear increase in temperature, and then we have it flat at 0 as we have a mixture of ice and water. When the ice is all gone, again we have a linear temperature increase as the water is heating up, and then it's flat at 100 as we have a mixture of steam and water. And then finally, at about 30 seconds, we have linear increase as the steam heats up.